Hey, so welcome back to more LeetCode problems. So today we're doing valid parentheses. If you didn't know, I'm going through the very famous Blind75 LeetCode list, which essentially just organize LeetCode problems by their particular problem pattern. So typically you'd see something like the stack pattern, which we're doing today. There's also trees like that data structure, and also dynamic programming and much more. But essentially we're going to do the stack problems today, and well, there's actually only one in this case. Previously I did like 8 in a row, so this is much simpler. And so all that stack pattern is, once again, is using the very famous data structure called a stack, which optimizes for pushing and popping the most recently used item. And so what we have here is different types of brackets. We have rounded ones, curly, and square. And so what we want is to validate this string. And that's essentially done just by 3 steps here. Essentially, the first thing is that, well, if we have an opening bracket, it needs to have a corresponding closing one. But also the type of bracket matters here. So you need to have like the same rounded closing one. It wouldn't work if it's, say, this curly one, right? So it has to match the type of bracket. And then the second thing is that the open brackets must be closed in the right order. And so what that means is that, say if you have a square, and then you have a rounded one, you have to have the rounded one that closes come before this square one is closed. How I like to think of this is kind of like a hierarchy. So we see the square, and then we have a rounded here. And then in order for us to go up a level again, we have to close this and then close this square one. So then if you kind of take this step further, where then we have a curly, we can't close this rounded one before we close this curly. All right, and so that would essentially look like a string like this. All right, and then the only other thing is that for every closing bracket, we also need a corresponding opening bracket of the same type. And all that is, well, something like this is not valid because we need a corresponding opening one. Also something like this, where we have the correct corresponding opening one for this square bracket, but we don't for this rounded one. Or I guess that would be more something like this is what I meant. Yeah, so we need that corresponding opening one. All right, so essentially for the implementation of this, the way we use the stack data structure is that whenever we see a opening bracket, such as these, we're going to push to our stack. And so if we keep using this example, like so, that and then that, essentially as we move from left to right and we're reading in this string, we're going to push to our stack whenever we see a opening bracket. So that would be like this, and then we see the square, and then we see the curly. And then when we see closing brackets here, we're going to look to the top of our stack, which at first is this one here. And we're going to say, okay, does this 2 brackets here match? And if they do, then we'll just pop it off of our stack, like so. We just kind of delete it from our stack, and we continue onwards. Otherwise, if they don't match, we want to immediately return false. And then so why don't we continue forward? So okay, now we're looking at this one. Does this match what's at the top of our stack? It does. So let's pop it off. And the next one, which is the rounded one, and once again, it's okay. And then so when we reach the end of the string here, we want to return true only if this stack is empty. And that is the case, so we return true. Otherwise, say that there's still a bracket on here, we want to return false. And then the only other thing is that, okay, what if we have a closing bracket here? Say we have an extra square. Well, we just reached this closing square bracket. We look to our stack, but it's empty. And well, that violates this third rule here. So if the stack is empty, but we stumbled upon a closing bracket, when we look at the top of our stack and it's empty, let's return false. All right, so I'll go ahead from this kind of intuition and we'll look at implementing the code. So essentially we're going to have this stack, and we want to return true if the stack is empty at the end of our program. But once again, we're going to be iterating through for every basically bracket here in our string. And we're going to say, okay, we want to push to our stack if it's an opening bracket. So if this bracket is basically an opening one, then let's push to our stack. But we have to have some way of knowing whether it's an opening bracket or not. And so to do that, we can quickly create a lookup table using a hash map. And I'll quickly show you what that's going to look like here. So essentially, we're going to map the closing brackets to the corresponding opening ones, like so. And we're going to repeat this for every type, and I'll explain why in a second here. So the square maps to that one, and then we also want to do the rounded. And so this just quickly allows us to do this in O of 1 or a constant time complexity of seeing, okay, is this a opening or closing bracket? But then also it allows us to be able to see if these two pairs are matching. Okay, so we can quickly see, okay, what's the matching pair for this closing bracket? And so to do this, all we have to say is, okay, if this bracket is in the right-hand side, so in our lookup table's value side, right? So if this bracket is on the right-hand side, then we know it is, in fact, an opening bracket. Otherwise, we know that it's a closing bracket, so it is a closing bracket. Then we want to do some other logic here. And so in that case, well, we want to return false if there's no corresponding opening one at the top of the stack. So first, okay, if the stack is empty, we most definitely want to return false because we're dealing with a closing bracket and we need there to be a corresponding opening bracket, but we also want to check the type. So, or if what is at the top of our stack, like so, if it does not equal the corresponding opening one that we're expecting, which is basically the current bracket, but we use our fancy lookup table to quickly see, okay, if we're seeing a closing curly, we want this curly opening bracket to be at the top of our stack. Otherwise, let's return false. But if this isn't the case and we're still dealing with a closing bracket here, then all we have to simply do is pop from our stack. So stack.pop. All right, so I think that's good. Let's go ahead and submit this, and success. So that's today's LeetCode problem using the stack pattern. So I hope that helped a little bit. Tomorrow I'll probably go ahead and do the sliding window problem, so feel free to follow for more and go ahead and check out my previous ones on two-pointers and arrays and hatching. Anyways, hope you have a great day and good luck with the rest of your LeetCode problems. Thanks for watching.